Hello everyone, I'm David. My project is UAV delivery system for water quality surveillance. This project proposed a novel water sampling method by utilizing the advantages of drones. The drones collect water sample and carry extra modules to perform diversification of functions. For example, carry a first aid kit or water quality testing device. It has the niche and great potential to be used in marine parks, water sports centers, hard-to-reach places, and other places that commonly use traditional sampling methods. It can replace sampling works with a drone instead of a speedboat, which simplifies the process, reduces the operational costs, and provides more flexibility in sampling location and time, achieving significant advantages. The UAV delivery systems available on the market focus on postal delivery, healthcare delivery, food delivery, and ship resupply. However, by and large, those systems required licensed professional UAV pilots because the systems weighs that exceed 7 kilograms and were expensive. Moreover, most packages, pickup, and delivery UAVs are unitary functions, like each model only has one or limited functions. Last but not least, they are closed source, thus users are not allowed to modify parts of the product. These reasons make them challenging to popularize to the general public or even small and medium enterprises. Designing a delivery drone to carry out low threshold and high cost-effective air logistics satisfy these requirements is essential. A below 7 kilograms multi-purpose UAV has mounts for users to fix and remove different modules, and is open source for people who know electronics to customize it. It will let people fly it in Hong Kong without the Civil Aviation Department's endorsement, enhance cost performance, and offer more possibilities. This design can help more small and medium enterprises and mini research teams with a small budget to enjoy the benefits of UAV delivery systems. In this project, we created a below 7 kilograms multi-purpose UAV that can carry various types of goods, collect water samples, and at the same time make flight control more user-friendly to users. The universal mounting can switch different modules under 30 seconds by a trained user. In the best case, it should be a helicopter, because this design can utilize flight performance. There is a hardware and a software control system for this project. The hardware contains a Pixhawk 4 flight controller, a global navigation satellite system (GNSS), a tachometer, an ultrasonic sensor, an optical flow sensor, a camera, one set of multi-rotor propulsion systems, a 2.4 GHz telemetry, and servo motors. This allows the project to connect to the ground control station for self-flight following pre-programmed waypoints, direct user control, perform various tasks, and monitor drone status with the aid of sensors and a camera. The drone currently has a cargo container module and a water sample collector module. These modules docking to the mounting mechanism expand the use of the drone and leave room for adding more features in the future. The cargo container module avoids package swinging, reserves space to place coolant and embed heater. The water sample collector module can release and retract a 2 meters rope, control the valves of the water sample collector with a servo motor, and prevent swinging. It does not require mobile network coverage as the Amazon Prime Air's quadcopter or catapult mechanism as the Zipline's fixed-wing drones reviewed in the literature review. Still, it needs to be operated under neither rainy nor thunderstorm weather. Moreover, load and flight time will be restricted to 1 kilogram and 15 minutes respectively. The figure above shows a basic diagram of the project. The system can be divided into 3 major parts: mechanical, electrical, and ground control station. The mechanical part contains all the components that directly let the drone fly and complete the missions. It has the 3 main parts. The first part is a multi-rotor driving equipment set. and its function is to provide lift force as required. Frame, battery, electronic speed controllers, motors, and propellers will be used to implement it. The second and third parts are external modules. Their functions are to provide different applications to the project. Self-designed structure and 3D printing will be used to achieve these aims. The electrical part has a flight controller to send and receive signals from mechanical parts. It acts as the coordinator of the drone. There will be additional modules and detection systems to provide sufficient information to it for making decisions. This part will communicate with the ground control station through 915 MHz. The ground control station allows users to configure settings and show the first-person view (FPV) received from the electrical part. The user can upload the helicopter's flight planning or direct control through the ground control station and joystick. This project still have so many future developments. For example, to create a landing gear to land safely and smoothly on the ground and water. It should provide enough buoyant force on the water to prevent damage unless wave height exceeds 0.1 meters, and also to improve the flight controller and its ground control station. Maybe implement other features including obstacle avoidance. This is the end for my presentation. Thank you and welcome for questions.